Hello and welcome to this video where we'll be talking about graph and optimization, second derivatives, first derivatives, graphs, domains, intercepts, intervals, and everything in between. So first we'll be doing this question here, question 19. It says summarize the pertinent information obtained by applying the graphing strategy and sketch the graph of y equals f of x, and then they give you f of x, and the first part of the question asks for the domain. So here's what you do. First things first, define your function. This part is an 8-9 part question, so it's well worth your time to define the function, be able to manipulate it easily. So this is it. 4x to the fourth minus 24x to the second. Sweet. Now they say, why not just plot the function? Just do f of x and then it will suggest plotting it, or you could just do the whole plot command. This is quicker for me. So now I already know when it's increasing, decreasing, where's the maxima and the minima, and all of that. But first, let's just take it step by step. First, they want the domain, so let's give them that. There's a nifty command called function domain. So function domain of f of x for x, shift enter, and it says true. When it says true, that means all real numbers because it's a polynomial. So the answer is negative infinity to infinity. And this is the answer. And the new part of the question, which asks for the y-intercept. Y equal. So the y-intercept is where you just set x equals to 0, so easily just do f of 0, and your y-intercept is 0. And now they want the x-intercept. Here's what you do for that. Come here and do solve f of x equals 0 for x over reals. And if you ever find yourself too lazy to do the solve function, you can just do this. F of x equals 0, and then it will suggest to solve it over reals, and it would be the same thing. So now you know your x-intercept is 0, comma, positive or negative, the square root of 6. Check the answer, and the answer is correct. Now they want the local minima and the local maxima. And here's how you obtain that. Solve f prime of x this time, which is the first derivative, equals to 0 for x. So now you know that your intervals are from negative infinity to negative square root of 3, then from square root of 3 to 0, from 0 to square root 3, from square root of 3 to positive infinity. We're going to get them numerical values because it would make it easier for me to try the number chart. And now we'll do a number chart. So f prime of x, sorry, not f prime of x, f prime of something before negative 1.7, since it's the first point, critical point. So negative 5, shift enter. You know it's decreasing on that interval because the answer is negative. And let's do f prime of something between negative 1.7 and 0, which is negative 1. Okay, it's decreasing here. And then we could do another point, which would be from between, so it's from, we did from before 1.7, and then between 0 and 1.7, which is negative 1. Now we will do between 0 and positive 1.7, which was just f prime of 1, positive 1. It's decreasing there because it's a negative answer. Now f prime of something higher than 1.7, which is just 5 for simplicity's sake and symmetry's sake. And now we know where is it decreasing, increasing, and whatnot. So you go and say it's increasing on the interval. So since before negative square root of 3, negative 1.7, if you're looking at the numerical value, since before that, the point before that, which is negative 5, came back with a negative answer, it's decreasing there. And then since between negative square root of 3 and 0, it's a positive number, then it's increasing there. And then above positive square root of 3 and infinity, which is f prime of 5, is positive. So that's where it's increasing, here and here. So let's record it as such. So from 0, increasing from, sorry, not from 0, from negative negative square root of 3 to 0, and from, we said, positive square root of 3 to positive infinity. So that being said, if it's increasing all the way from negative square root of 3 to 0, 0 is where it stops increasing, well, that makes it your maximum. So the local maximum is at 0. Let's check the answer. It says correct. Now it comes back asking me for the minimum. Let's screenshot that. Now they want the minimum, so let's do the decreasing intervals. Okay, let's just do it here. Decreasing is from negative infinity, because as you see at negative 5 before our first critical point was negative. So from negative f to negative of 3, square root of 3, and also decreasing from between 0 and positive square root of 3, because of this point here, f prime of 1 is negative. So this is your decreasing sub interval. With that being said, if it's decreasing all the way from negative infinity to negative square root of 3, and then it's decreasing from 0 to square root of 3, that means you have two local minimum points. One being at negative square root of 3, the other being at positive square root of 3. So we'll just do negative positive square root of 3, check the answer is correct. Now they want the let's screenshot that. So the answer is correct. Now they want the inflection points. The inflection points have to do with the second derivative. So you do f prime prime of x. You see how it's always worth it for you to define f of x. Now you can get the 10th derivative if you want, just by adding primes. So f apostrophe apostrophe of x, or f prime prime of x. Shift enter. This is your answer. But what I'm more interested in is the solution of this. So we'll ask it to solve for reals. There's my two inflection points, negative 1, comma 1, and that's it. And now asking for the increasing, decreasing, which we already settled up here. So let's just copy it. Increasing from negative square root of 3 to 0, positive square root of 3 to infinity, then decreasing, negative infinity, negative square root of 3 from 0, positive square root of 3. Let's check the answer. We messed up the parentheses. Put it in the radical. Okay, now it's correct. And now they want the decreasing, now they want the concavity. So hold on, let's just first screenshot this here answer. So as you see, we got the increasing, decreasing intervals correct. Now they want concavity, which has to do with the infliction point, which has to do with the f second prime of x. So since our inflection points is at -1 and 1, we're going to try points before -1, between -1 and 1, and after 1. So f prime prime of -5 is positive, so it's concaves upwards there. Then f prime prime of what's between -1 and 1, 0. That's negative, so that concaves downwards. F prime prime of what's above 1, 5. And that concaves upwards. So let's do just that. From -infinity to -1, concaves upwards, comma, from 1 to positive infinity, also concaves upwards, then for downwards, from -1 to 1. Check the answers, that's correct. And now they want the graph, so that is just literally as simple as doing f of x and clicking on the plot suggestion, and you can see it. It looks exactly like what's it called? Looks exactly like C, albeit you can't see the concavity as extreme as you can in the graph C in the option. That's just because Mathematica put an incredibly large range on this plot of 4,000 versus where my assignment put a range of 40, which is more fit and shows you the concavity better. But you can see the shape, it's pretty obvious. This is it. You can see it. This matches with C. Did I say D? I meant C. So let's click C, and the answer is correct. And this concludes the video that covers graph optimization, increasing, decreasing intervals, inflection points, critical points, concavity, plotting, graphs, domains, and intercepts. The whole shebang. Thank you for watching. Have a nice evening.